This tube is a air conditioning tube, copper, skip finned, 28 wall, 3/4 OD. I'm in the tube. I'm strobing through and looking for the circumferential crack, and I'm going to strobe back and forth a few times and watch the lavender and the blue signal go from upper left to lower right, not losing any peak-to-peak voltage. And the other thing I want to point out is that the amplitude, which is the orange, and the green signal, which is the differential, is off scope. And if you have a crack in the landed area, which this does, you'll not see it except by the T5. That's the purpose of this demonstration, is to show the value of the T5 probe. Now I'm going to stop that, slow it down, capture it, see if I can put on the screen here and show that. This will be the amplitude signal. This right here is saddle damage of 10 thousandths. My differential is the green. It goes off scope, saturates. This is 2K. Differential is 20K. For the T5, this is 20K signal, and this is 2K signal. So I've got the amplitude, or the absolute signal, and the low frequency TK, T5, the same frequency, and the differential and the high frequency T5 at the same frequency. So both coils are run in differential mode using the same frequency that you use for the differential, making the test simple and able to be used on any piece of test equipment. Strobe back through, and the signals that I'm looking for right now are these right here, T5, and they go back and forth through, so they're not going to miss any defects. So when you're testing with the T5 and the improved differential set of coils, you're going to be able to document your report based on previous reports for defect analysis, trends, and you're not going to miss any defect from tip to tip, which is why it's called T5 hybrid. T5 stands for tip to tip testing, tube testing, tip to tip, and the hybrid part is the also the differential pair, coil pair, in the same housing. This is another air conditioning tube. It's this free span area. It has an OD ring of 360 degrees around, and then OD hole 50% through, OD flat bottom hole 50%, 2 through-all holes of different sizes, and 2 ID pits cut into the inside of the tube itself. So here's what that standard looks like, and I'll strobe it. There's out the tube, and that's what I'll stop that to show you more. But here's the thing I want to point out. Here is the OD ring on the absolute, the orange signal, and the differential, which is the green signal, showing major metal missing, yet the two lower dots, the T5, have a horizontal movement, which is residual left over from the machining on that tube itself. And so it completely subtracts all the metal missing. It's 360 degrees around, and if that was a support signal, that also would be erased. I'm going to go out the tube, bring it back, and strobe it. Capture that signal. Let's see if I caught it. Yes, I did. So then I'm going to bring it up, put my cursor on it. Okay, I'm going to narrow my window. I'm going to narrow the cursor so I can get a better view. Now I'll move it back down to the beginning. Okay, you can see on the scope that this is the amplitude signal of all the OD metal missing showing up at 20% on the differential, and the two T5 coils staying on screen and visible, being able to look at whatever's there on the screen. So as I go through, and there's about 1.5 inch difference between the coil pair, so there's a 50% through wall hole on the OD side showing up on the amplitude and the differential, and slightly further you'll see that show up on the T5. As I go further into it, we have a through wall hole showing up here and here, and will be showing up also here. And as I go through the other defects, watch the green signal. That's another through wall hole on the amplitude and the differential, showing that standard in its total. So as I strobe through it quickly, all the defects show up except the 360-degree OD ring, and it does not show up, which is the purpose of the T5 set of coils.